In this lab, we will look at the data collected for the missing soap saga. The company manufactures and markets a well-known brand of toilet soap, which it sells in cakes having an advertised weight of 150 grams. Lately, it has been warned by the Department of Weights and Measures that some of its cakes of soap have been found to be underweight. In order to explore how the weight of the soap bars changes with storage, a sample of 25 cakes of soap are stored for 10 weeks after production. At the end of each week, the soap is weighed and the average weight recorded. For the starting, the average weight is 153.5 grams for the 25 soaps. After 1 week, the average weight is 152.8 grams for the 25 soaps. And after 2 weeks, it's 151.4. And after 3 weeks, the average weight is 150.4 grams. After 4 weeks, it's 149 grams. After 5 weeks, the average weight is 148.4 grams. After 6 weeks, the average weight is 147.3 grams. After 7 weeks, the average weight is 146 grams. After 8 weeks, the average weight is 145.2 grams. After 9 weeks, the average weight is 144.7 grams. And after 10 weeks, the average weight is 144.2 grams. What is the dependent variable? The response variable. The response variable is the mean weight in grams for the 25 soaps. What is the independent explanatory variable? The time in weeks. Construct a scatter plot of this data and guess the value of the correlation coefficient. What does this mean? Okay, so we want to plot the scatter plot. So click in an empty cell and click on Insert. Click on Chart. Click the chart type and select Scatter plot. Scatter chart. Let's move this to on sheet and let's edit the chart. Let's add the data. So the data, the first is, let's select the time in weeks and let's select mean weight in grams. Click on OK. And let's customize the chart. For the chart and axis title, for the horizontal axis title, tap the title text, time in storage, and that's in weeks. And for the vertical axis title, type the title text, average weight, and that's in grams. And for the chart title, type the title text, soap weight, that's average soap weight, versus storage time. Let's look at the grid lines and ticks. Okay. Let's look at the vertical axis. And for the minimum, let's have 140, say 100. 140, let's have 140. And for maximum, let's have 156. For the horizontal axis, for the minimum value is all right. For the maximum, let's have up to 20. Okay, so this is the scatter plot of the data, and guess the value of the correlation coefficient. What does this mean? Now for the correlation coefficient, it will be a negative value, and it will be very close to -1 because it shows a strong linear negative correlation. So it could be minus 0.95. But to calculate that, we type equal correl, select the dependent values, comma, select the independent values, and that's negative 0.994. How much approximately is the soap weight decreasing per week? So by looking at the chart, it looks like it's decreasing. For every week is decreasing by 1. Let's have the tick marks in steps of 1. Customize, grid lines and ticks. And for the horizontal axis, major spacing type step, major step 1. Okay. So for every week, there is the soap reduces its weight by about 1 gram. Hence, write down the approximate equation of the regression line. So to find the coefficients of the regression equation, type equal lineast, choose the dependent values, comma, space, select the independent values, close the bracket. And so the equation is mean weight equal to 153.354 minus 0.981 times time. What do constants in the regression equation mean? So the 153.354 means the average weight of 25 soap bars in the start, and minus 0.981 is grams is the amount that the soap average weight of the soap reduces for every week. what is the value of the correlation coefficient? So the correlation coefficient we calculated, and that's minus 0.994. And what does R squared mean in this context? So correlation coefficient is R, and R squared will be square of correlation coefficient. And that's about 0.989. So the correlation coefficient is the amount that the weight is, how strongly the weight is correlated with time. And this shows that it is a very strong correlation. Weight is dependent on time very strongly because it is very close to 1. Predict the average weight of a cake of soap after 6 weeks and 10 weeks. So let's add it to this table. So after 6 weeks, so predict the average weight of a cake of soap after 6 weeks and 20 weeks. So 6 weeks is here, and then 20 weeks is something, 20 weeks is extrapolation. So let's predict for this as well. Let's predict the mean weight for all the time, the observed time, and include the 6 weeks and 20 weeks. So that's 153.354 minus 0.981 times time. And let's copy that to all the cells. Okay, so for 6 weeks, the predicted value is 147.468 grams. And for 20 weeks, the predicted value is 133.734 values. Now let's add this predicted mean weight to the chart that we plotted, the spreadsheet that we plotted. So let's edit the chart. And for the data range, let's remove all the data range and then reselect. So we select the time, then we add another range which is observed mean weight values, then add another range which is so we add the mean weight values, add another range which is the predicted mean weight. Okay, let's add the series predicted mean weight. And for 20 is 133.734. So we need to edit the chart and we need to customize the vertical axis. Let's remove the minimum value. Let's have the minimum value as 130. Okay, so for 20 weeks, the average weight is not very clear. Let's change the horizontal axis minimum and maximum value. Let's change the maximum value to 20.2. So now it's clear. So for 6 weeks, we predicted this 6 weeks value. So let's color that differently, say green. And for 20, that's wrong. Put it back to red. For 6 weeks, color that green. And for 20 weeks, let's color that green. Okay, so for 6 weeks, the predicted value is interpolation and is reliable with the observed values. But for 20 weeks, it's extrapolation and is unreliable because it's not in the range of the observed values. What reservations do you have regarding these predictions? So for 6 weeks, it was interpolation and is reliable with the observed values range. And 20 weeks is extrapolation as it's unreliable data because it's not in the range of the observed values. Sketch how you think the soap weight is related to time. So the sketch, so this is the spreadsheet, and the soap weight is decreasing as the storage time in weeks increases. Okay, now most soap is sold within 6 weeks of manufacture, as we can see in the data. So within 6 weeks of the manufacture, most soaps are sold. What could the company do to assure that the soap complies with the PEC labeling? Well, what the company can do, because in 6 weeks, we can see that the soap weight decreases to about 147.46, which is a 3 grams loss. So the manufacturer company could sell within, say, 1 week. Where is 150? Yeah, so within 3 weeks. Within 3 weeks of manufacture of the soap, the manufacturer company needs to sell. residuals. For each value, we can calculate the residual or error. Residual equal actual value minus predicted value. Residual equal y minus y hat, where y hat equal 153.354 minus 0.981 times time. Complete the table to the right. So time values are given, and we could add even for 20. Let's say 20 as well. And for the to predict the values, 153.354 minus 0.981 times time, and copy the equation to the rest of the cell. And then for the for the residual, we do predicted value minus the observed value. Okay, so now, so that's the table. Now plot the residual plot, which is a plot of the residuals versus the independent variable x. So click in an empty cell, click on Insert, click on Chart, and then select Scatter Chart. Let's take this to the on sheet and click on Edit Chart. And then let's select the time range and then add another range, and for that we will select the residual. Click on OK. Now we have this plot here. So let's make some changes to this residual plot. Let's customize. Click on Chart and Axis Title. For the horizontal axis title, type the title text time, bracket, and that's in weeks. And for the vertical axis, type the title text residual space, and that's in grams. And for the horizontal axis, let's choose the minimum to be the maximum to be 11 weeks. And for the vertical axis, let's select the minimum to be minus 0.6 and maximum to be 0.6. Let's say 0.8. Now for the horizontal axis, number format, we select none, and grid lines and ticks. For the horizontal axis, we have the steps in one. And for the vertical axis, we have major spacing type step, and the major step we have 0.1. Okay. And for the chart title, let's put the chart title. Residual plot for soap weights. What does this show? This shows this is more like in U shape. So describe the pattern here. The residual has a U pattern that shows that a non-linear model would be more appropriate. Perhaps this means that the weight loss will tail off. Weight loss will tail off. Okay. So next question. What implication does it have for predicting weights of cakes of soap? The prediction, particularly for 20 weeks, will be unreliable. Whereas for 6 weeks, the prediction is reliable.